new to me. But when I was in the initial stage of job search, I was also exploring the design verification field, which was I felt that it was more of coding. As I'm a electrical and electronic based student, I am not that well versed with embedded C programming. So I just quit design verification and got an opportunity in manufacturing domains, which is also very interesting domains. So what are the things I need to focus so that I can grab an opportunity in product based company? In with respect to product based company, like what skills they are expecting to? No, I have I'm a graduate, last year graduate. Yes, I am working in IAC.
Yeah, sure. So thank you. My background is from electronics, but like I just got into software testing after my graduation. So I'm trying to switch to front end VLSI. I My inclination is more towards on the front end side, not well versed with back end and post silicon. So I know, but some of the skills are common across the VLSI stack, right? Domain wise for some of it. But I want to like enhance my skills with respect to verification. Could be front end, simulation that we do, uh, or even formal verification because the intent the goal is the same in both of it, but the intent does vary, right, when we are doing it. So I'm trying to get better clarity and focus mainly on, the job requirements, like to clear interviews first. Because learning is going to be long. I have to learn even after I get in. But because I'm doing it by self learning, it's been challenging on and off. Sometimes I'm looking for guidance with respect to this. Yes, sir, it is. Oh, sorry, I was muted. Uh, you're audible, but the screen share did get stopped, isn't it? Or maybe, I don't know, my connection. Yeah, now I can see, I think, sorry. Maybe there is latency with respect to my connection. Yes, it is. Thank you. Uh, so there are a few things to consider. Just because your test case is passed doesn't mean that your test suite is complete. You do have to look at other variants, right? For example, if you're testing some feature, but as a system, has there been other features that have been updated, and is there any feature interaction? Or could be also that you have just missed covering certain things. I know we do coverage reports, but that's also one thing to consider. Uh, at least this was one main point.
There is no guarantee that verification is complete in any case. It, there might be found in at any stage. Once again, shouldn't fail means what? I didn't. Sorry, I missed informal. Can you explain informal once again?
I know the basic idea of an arbiter, but I'm not designed or verified it.
Even our simulation also will write assertion. If we 2 times 2 grants are coming assigned means it will catch there. Okay, it should not assign or that is driving input driving is wrong. So we'll modify the input driving and we'll drive properly so that only one. If design is not expected to do that, then we'll get assertion error. Or some scoreboard error also will be there because it is not having handling that.
Sir, I have a couple of clarifications. So the scenario is, uh, I understand there are multiple masters in this case, two, at least two, and we are talking about grant. for a request that has been sent from a slave or, sorry, from a master or multiple masters. But when you said, are we verifying that the DUT should only send one grant to one of the master, though it receives multiple requests? It should never send two grants. Is that the scenario? Okay. If that's the scenario in simulation, just because I'm not that very, my skill level is not completely complete in verification also, though I want to get into it, we might verify that within our test bench, right? Right. So even when we have to do something like this in a simulation, we have to write an assertion saying that, like, forever in the clocks or something, anytime there is a grant from the DUT, that signal, right, it has to only go to one of the master. The other grant has to be low during that time, any of the other grants, right? This kind of assertion we do have to write. But you're saying that to come up with the simulation environment itself is time consuming and resource weird. Right, we define the scenarios. Right, there are certain things which we do in simulation, there are certain things which can be less time consuming when we do it in formal. We are probably hinting towards that. I'm following that point, right? But just maybe once I have to be able to practically, like, walk through something and also see how it is happening to get a better understanding. I think for now I'm sort of following what you mean. One thing I didn't follow was, when you have 1,000 test cases, writing that in a SV or a UVM environment is going to be difficult, you said. But when we do cover it in assertion, it's not like we are going to write out those 1,000 test cases, but we are going to write the behavior very correctly or as precise as possible so that the tool will come up with all those test scenarios. It could. Yeah, it could, I think. Sure. Okay, sure. Okay. No, formal tool, no. That's why I'm just trying to like imagine and follow what you're saying, right? For some of it, because I don't have a proper reference. Like the main thing currently is simulation. I follow your directions of the arrow mark you have used, right? So for formal, you are defining the behavior to the tool, or is the tool giving it to us?
You mean that
Uh,
for every
yes, sir.
property you write, you'll be getting the tool will generate say, its inputs based on the property you have written. If I write ba- based on the property, it will tries to generate inputs to break that property. How it will break like different combinations of inputs. Is it correct? Okay. Yeah, understood. Good.
Yeah,
Please
there
go
is a
ahead.
big picture and a small picture, like the detailed picture, right? To get both of them together can be challenging. Yeah, like currently just trying to get the big picture so that, later we can go into like granular details, right? When we do write out, like for an example, the scenario, maybe that will become more clear. Yeah, unless we have done that, we have covered that path too. But when you said the number of states, here you have more number of states, right? Like at least, like, is this, how many state missions do you say this is? How many states are there? You mean if the full flag has to be high for a scenario? Yeah, the precondition or a prerequisite is that you do have to simulate that scenario, right? I mean, you have to have your like the test bed in a way. You have to get it ready in the terms your FIFO has to be full. You load the data in.
Once again, the
So it is
design
not.
is once again. Sorry, the design is SystemVerilog RTL only, na? You mean that we are using gate level netlist is in the
Yeah.
yeah RTL which is synthesizable. For that RTL synthesizable model, to verify that you are creating some behavioral model or some what?
No, the way I understand what sir just now said is, if I'm wrong, please correct me, sir. When you do simulation, it is this is before synthesis, right? Pre-synthesis simulation is zero delay simulation, right? Or we call it that unless you have put delay purposefully, you do that. But there is no gate level delay there. But when you've synthesized your design and then you're performing a simulation on it, right, with a gate level netlist, actual delays are compensated, like how you have it in real hardware. Yes. Correct, sir. Okay, so you mean to say that because we do post synthesis simulation, right? Gate level simulation. So where there are tools which have netlist and they do have delay, but here in formal verification, though it does use like a synthesized version of the RTL, but it's not like complete, right? Yes, we have requirements or specifications, and we can write our formal verification environment or test scenarios from there on.
It is burst type, no? I think so. Burst. Uh-huh. So you mean that you will be fixing to one input and will be verifying the how it will come. So that okay. Yes, yes. Please go ahead.
So, for example, So for example, like BCS we use in front end simulation, like that you mean to say some other formal tools similar to that which are there for formal verification? Okay. So if there are race around conditions or some deadlock conditions for the request grant kind of model, it recognizes that stuff. So the input is our yeah, the RTL design is itself the input for a formal verification. Okay, as long as if there is something which is incorrect in the designer who has written that RTL from the specification, that bug is sort of present when formal verification tool refers to it. It can either recognize that there is a bug, but it doesn't know the specification. It could get missed as well, right? Yeah, it is trying to like give us the stimulus for which that scenario can be triggered. You just wait for that signal, that event to happen. For example, if it's for a master 2, like the grant 2 signal, you're monitoring it. So in this case, because like you're saying, right, like good thing eventually happens over there. Sometimes if depending on the arbiter algorithm we are using, some masters get priority over others. So it can vary. Like I can't say the time, right? Yeah, like that deterministic time we can't give, right?
Yes, able to follow. Myself, I be able to follow. The only things I want to double cross check. Safety property is like the safer one, which is definitely will work. Liveness means where the we required to wait for the simulation 1,000 clock cycles, then only we get hack. In formal, you are saying that that will be mathematically will be calculated and check ahead. No need to wait up to 1,000 clock cycle. Is that understanding is correct?
Yeah.
Okay.
Yeah, the
Okay.
opposite of what you're trying to say.
Yeah, green and red should not be same time. Got it. Safety property. Okay.
No, no, like for two of the like in the junction there are multiple traffic light signals, right? What sir
Uh-huh.
meant is when 2 green, meaning that you have one array of lights, 3 lights, and another array. In simultaneously, the green light in both of those different arrays should not be on.
Got it. Either one. A malfunction one should not happen.
Safety is like in English what it means, na? That you are safe. It will safe from something bad. That bad thing doesn't happen is what we are checking.
Hmm. 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 Correct. But does it will wait for 1,000 clock cycles, or how it will? Correct. Okay.
Sir, excuse me, sir. Just one point in the previous slide, that second point, you mean to say you have ran your formal verification and some check is failing, and you want to understand what stimulus resulted in that failure. So, AI can help in providing that example stimulus? Like, yeah, what kind of bug it is, and like an example stimulus that results in that bug. So AI can help provide that information, you mean? Okay, that's how the bug got hit, you mean? Yes, and it can help to explain this scenario, you mean? Right. Yes, we should be able to we have to discern that.
Yes, yes, yes. True. Mhm.
Sir, I had one doubt. Sir, can we run the scan chain insertion and built-in self-test also during formal verification? Yes, sir. Like we generated the netlist and finally in always check we want to check the both things. Yes, sir. I got it, sir.
Sorry, can you repeat? RTL to synthesis, you will check another point. Uh-huh. Okay. Okay. Correct. Okay. That how you'll do means now say once again, let me clarify. Say first initially we have had one RTL one, and we developed one assertion, assumption, or spec behavioral model, or some development will do. Now we'll replace with this RTL with the GLS to verify that the same model is equivalent to GLS or not. Is that process is correct? Okay. Mm, 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 mhm, mhm, mm. Okay. Okay. Okay.
I wanted to ask what was the name of the app you said for formal verification? Sir, do you give complete like training on these tools in your Instagram as you have stated, or are there any courses? Okay, sir. So, yes, sir. I think from my side it was clear.
Yeah, thank you, sir. Would really appreciate that because it's a different thing also sometimes. When we do simulation, like I was trying to say early on, we might not think in this way or analyze in this way. So there is a reason why we have both the things, right? And need to wrap my head around some of it, go through the examples, and like do compare and contrast. Sometimes like some small exercises and stuff will do. You had included some examples. I'll try to look into some of that. Like FIFO is a simple one, but still to do it in this way, it will actually help, right? To go through. Right. Yeah, definitely. Sometimes some simple examples can actually help to understand it. It's just that we have to come up with it, right? To work through it. Mm, sure. Other than Yosis, which is requires a Linux environment, am I correct? Okay, sure. So other than that, there is no open source tool where we can do formal verification. Is that correct understanding? Okay, all right. We'll look into it, sir. Thank you.